Yes, we have a question from the matrices. If A equals to 1, 1, 1, 1, and we have to find the A to the power of 100. Here, A equals to 1, 1, 1, 1 is a square matrix where all the elements are 1 itself. We need to find A 100. Here, given that A equals to 1, 1, 1, 1 and its order of matrix 2 into 2, we need to find A to the power of 100. First of all, let us find A square. A square, which is equal to A into A, which comes out to be, by the calculations, 1, 1, 1, 2, 1, 1, 1. It comes out to be, by the calculations, 2, 2, 2, 2, which is nothing but 2A. Now, A to the power of 4 is equal to A square into A square, which is equal to 2A into 2A, which is equal to 4 into A square, which is again the A square is equal to 2A, which comes out to be 8A. Now, we have proved that A to the power of 4 is equal to 2 to the power of 3 into A. This is because 8 is equal to 2 to the power of 3. Again, by taking this result A to the power of 4, we can find out A to the power of 8, which is A to the power of 4 into A to the power of 4, which is equal to 2 cube A whole square, which comes out to be 2 power 6 into A square, where A square is equal to 2A, because we have proved in the initial steps itself, into 2A, which comes out to be 2 power 7A. On comparing these two results, A to the power of 4 is equal to 2 power 3A. A to the power of 8 is equal to 2 to the power of 7A. Yeah, in this we have finding some similarity that A power n is equal to A power 2 power n minus 1 into A. Now, A 100 is equal to 2 to the power of 99 into A. This is the final result which we need to find. Hope you are clear with the solution. The next question is as follows. Here we need to find the transpose and then we have to equate it to the unit matrix I. Yeah. Here A is given out to be A equals to matrix cos theta minus sin theta cos theta. Now, first we have to find A transpose, which is equal to cos theta minus sin theta cos theta. Now we need to find AT plus A, which is equal to 2 cos theta sin theta minus sin theta cancels and 0 remains. Here also 0 remains as minus sin theta cancels. Then here it comes out to be 2 cos theta is equal to I of order 2. We know that I means 0, 1 unit matrix. It is one diagonal elements are 1 and another are zeros. Now, if we equate this, now let's equate this. 2 cos theta is equal to 1. It means cos theta is equal to 1 by 2. Cos theta is equal to 1 by 2 in the interval of cos theta is equal to 1 by 2 when the theta is equal to 2n pi plus pi by 3. So our answer is theta equals 2n pi plus pi by 3. So our answer is C. Yeah, friends, let's come to the next question, which looks like a complex, but it's very easy. It's nothing but algebra. That's all. Yeah, here if A is equal to 0, 0, 1, 0 and I is the unit matrix of order 2 and A and B are arbitrary constants, keep a look on the capital A and capital B and small a and small b, because it seems to be confusing to us. Small a and b are constants and the capital A is the matrix. Now we need to find AI plus BA whole square. It looks complex, but you will be able to know shortly. Now here A is equal to 0, 1, 0, 0. Now I is equal to, or unit matrix. We need to find AI plus BA whole square. AI plus BA whole square, which is equal to A square I square plus B square A square plus 2AI into BA, where I square is equal to I itself. So it comes out to be A square I plus B square A square plus 2AB A, because any matrix multiplied by the identity matrix I is always a matrix, same matrix itself. So I wipes out from here. Now let us find the A square, matrix A whole square. A square is equal to 0, 1, 0, 0 into 0, 1, 0, 0, which comes out to be 0, 0, 0, 0, which is nothing but 0 itself. So let's substitute the value of 0 in this equation, where AI plus BA whole square becomes equal to A square I plus 2BA. This is because from this equation 1 we have substituted the value of A square. Hence the answer is A square I plus 2BA. Yeah, we have a next question. If A is a square matrix, then A into A transpose is a symmetric matrix or skew symmetric matrix. Let's start the solution. Yeah, let us find whether this matrix is a symmetric or skew symmetric matrix. The matrix to be a symmetric matrix, the matrix and its transpose should be equal. If it is skew symmetric, then the matrix and its symmetric matrix is equal to -1. Now, let us find this transpose of the given matrix. We remember a formula that x into y whole transpose is equal to x transpose into y transpose, which means here A into A transpose whole transpose is equal to A transpose whole transpose into A transpose. Here A transpose whole transpose is nothing but A itself, and A transpose T is equal to A transpose T, which is same as A into A transpose T. This implies that matrix is symmetric matrix. Hence, this solution is option A. Option A. Here the main thing is we need to remember the formula, that is x into y whole transpose is equal to y transpose into x transpose. This completes the problem. Hope you are clear with this. Here we have another question. Let A, B and C be n into n matrices. Which one of the following is a correct statement? We need to identify the correct statements in the below options. I will clear-cut look at these questions 2 times or 3 times because it's very good question choosing. Come, let's look at the solution, how it comes. Now, here the first option is, if A, B equals to AC, then B is equal to C. We need to look whether this option is correct or not. Now, let us take AB is equal to AC, multiply by A inverse on both sides. A inverse B equals to A inverse C, which becomes IB is equal to IC, where I is the identity matrix. So any matrix multiplied by identity matrix, the matrix itself is the answer, which is correct. Now, option A is correct answer. Now let us check for option B. Option B is, if A cube plus 2A square plus 3A plus 5I is equal to 0, then A is invertible. Here, first of all, let us look for an important thing in this, because if any equation is of the form A0 plus A1x plus A1x square so on to plus A n minus 1 to x power n is our equation, then that is invertible. That is invertible. Condition is A0 should not be equal to 0. Here in this equation, since phi I, which is equal to phi itself, so we have A0 not equal to 0. So this is invertible. This is invertible. Invertible matrix. And next, option C is, if A square is equal to 0, then A is equal to 0. We need to check whether A is equal to 0. They have given that A square is equal to 0. A square is A into A is equal to 0. Multiply by A inverse on both sides. A into A inverse is equal to 0 into A inverse. Here A into A inverse is I. I into A is equal to 0 into A inverse is 0 itself. So A into I is A. So A is equal to 0 is again a correct answer. Again a correct answer. answer. So our answer is none of these, option D, which is none of these. In these type of questions, we need to multiply by the A inverse or whichever matrix comes. Then our solutions become easier. D, none of these is the correct answer. Is correct answer for the above question. This is very important and easy question. Hope you have understood the solution. Let us proceed to the next question. Now we have another very important and easy question. If A is a square matrix such that A minus 2i into A plus I is equal to 0, then we need to find out the A inverse. Come, let's look at the solution. Here, nothing is there but only algebra we need to solve. A minus 2i into A plus I is equal to 0. Now, if you multiply this, A square plus AI minus 2AI minus 2I square is equal to 0. Here, now, A square minus 2AI plus AI comes out to be minus AI minus 2, because I square is nothing but I, is equal to 0. Now A square minus A minus 2I is equal to 0. Here, if we take A as common, then A into A minus I is equal to 2I. Minus I becomes plus I. Now, the 2 comes to the denominator. A into A minus I by 2 is equal to I, where if this A goes to that side, it becomes A inverse. A inverse into I is nothing but A inverse. So, our answer is A inverse is equal to A minus I by 2. This is the required answer. Hope you have understood, and it's very easy. Here we have another question. Square matrix P satisfy the equation P square is equal to I minus P, where I is the identity matrix. If P to the power of n is equal to 5I minus 8P, then n is equal to. This is another question similar to the first question. For all these type of question where the exponential function comes into the play, we should follow the same way as question 1. Come, let's have a look at the solution of this. Solution. P square is equal to I minus P. Then P cube is equal to P into P square, which comes out to be IP minus P square. Sorry, it's P cube. Similarly, P to the power of 4 is equal to P into P cube. Yeah, friends, here I have written the wrong answer. it is 1 IP minus p square, which is, if we simplify it again, we get pi minus I minus p. This is because we have substituted the value for p square here, which comes out to be 2p minus I. Now, p into p cube. P cube is 2p minus I as proved above. 2p minus I, which will be equal to 2p square minus p. Again, by substituting the value of p square, we get 2i minus 2p minus p, which is equal to 2i minus 3p. Now, let us find out the value of p to the power of 5. P to the power of 5 is p into p power 4, which is equal to p into 2i minus 3p, which is equal to 5p minus 3i. Next, let us find p to the power of 6. It is equal to p into p to the power of 5, which is equal to p into 5p minus 3i, which comes out to be equal to 5 into I minus p minus 3p square. This is by the algebraic substitution, which is equal to 5i minus 8p. P to the power of 6 is equal to 5i minus 8p. Well, this is the required answer, because in the question they were asked that p to the power of n is equal to 5i minus 8p. So, the value of n is equal to 6. This ends the solution. Hope you have understood.